So for today's work, we're just going to be taking a look at evaluating some expressions. Simple enough, straightforward enough, I hope. But a lot of it's going to be focused on some order of operations, detailing work as we go, as you're going to see. So, for this first one, notice we're told that x equals 1. So that tells us to start by plugging that in for x. Because we're going to evaluate it, which just means figure out what it equals. So, I plugged the 1 in for x. Notice that's all I did here. That's the only difference between these two lines, is plugging the 1 in for x. Then, we just have to follow the order of operations. Now, think about, what are you going to do first here? And the trick is, remember, order of operations, PEMDAS.
Wait, would you not do the thing?
You got to do the stuff inside the parentheses first.
What? Really?
So we have to do the 1 plus 2 first. That's why PEMDAS starts with parentheses, because parentheses are basically a way of writing out on paper, hey, do this part first. Before you do anything else, do this first. That's what parentheses really mean in math. And so we start by doing that. Now, having done that, we're still thinking PEMDAS. I did the stuff inside the parentheses, so there's nothing more to do to that number right there. Next is exponents. Well, there aren't any exponents. Then it's multiplication and division. Now, there is multiplication and division here. That's the multiplication of 3 times 3. Notice you have to do that 3 times 3 before you do the subtraction. Subtraction should be the last thing you do. Unless it's inside parentheses, it's the very last thing on the whole list. So we end up doing 5 minus 9 here. And you'll notice, since we're doing 5 minus 9, we're taking away more than we start with, therefore it should be a negative answer. So you should get an answer of negative 4. All right, next one. 5 times 2 to the power of x. One big thing I want to point out here. This is not the same as 10 to the power of x. We cannot do that. So, why not? The 2 is to the power of x, but the 5 is not. The 5 is just a number being multiplied out front. So, first thing I'm going to do, plug the 3 in for x. All right. Now, what do I need to do first? The multiplication or the exponent?
Exponent.
The exponent, yeah, PEMDAS. There aren't any parentheses for the p, but e for exponent, yes, we do need to do that part first. That means doing 2 cubed. Now, 2 cubed, remember to cube something means multiplying it by itself 3 times. So I'm going to be doing 2 times 2 times 2. 2 times 2, of course, is 4. And 4 times the other 2 is 8. Now you can actually do that in your calculator as well. And once we've done that 2 cubed, we now have 5 times 8. Well, that's the last thing to do then, is just do the 5 times the 8. So the whole thing just equals 40. And we're done. All right, so we're next going to be tackling these two problems. Now these two problems are really the same kind of stuff as you just saw, except that I wrote it slightly differently. I wrote find f of 2. And remember, that's how we read that. It's not f parentheses 2, it's f of 2. This is function notation. When I write that, basically I'm saying find the value of f of x when x equals 2. It means the same thing. And so notice the similarity between this and the last one. It's the same idea. Plug the number in for x. The only difference is just the notation I used to write it. So step 1 on that first one, I plug the 2 in for x. All right, so first thing we do here is we do the exponents, because exponents come before the addition, which is the other possible operation. So 5 squared is 25, because of course 5 to the power of 2 is 5 times 5. And then I do the 25 plus 3, and we can see our final answer is 28. Notice on these, the f of x from the original problem, I rewrote it as f of 2 once I plugged the 2 in for x, and then I just tracked down f of 2 equals f of 2 equals. One of the reasons why this function notation exists, why we write it this way instead of where x equals, is that it allows us to look at this final answer, and it tracks both what we plugged in, the 2, and what we got out, the 28. All right, for the next problem, same process. We're going to take the 7 and we're going to plug it in for x in the original equation. So that means we're going to be doing 10 to the power of 7 minus 4. Now with this one, you got to be kind of careful because it can seem a little bit tricky here. The 7 minus 4 is the exponent. So if I'm going to be doing 10 to the power of that, I have to figure out what that exponent actually equals. In other words, there's like invisible parentheses around it. We have to do that part first. And so we end up getting 10 to the power of 3, which is 10 cubed. And then we figure out what 10 cubed is, which, by the way, again, you can do that without a calculator, because if we're going to be doing 10 times 10 times 10, well, 10 times 10 you know is 100. And 100 times 10, hopefully you know it off the top of your head, but if you don't, you just take your original number and you add a 0 for it. And so you notice it equals 1,000. And so that's our final answer. We can see then that f of 7 equals 1,000. Another cool little trick with this, you notice 10 to the power of 3 equals a 1 with 3 zeros after it. If it was 10 to the power of 20, it'd be a 1 with 20 zeros after it. Makes it nice and easy. All right, so now as you're working these through, your first step, of course, it's the same, right? We got to start by taking whatever x equals and plugging it in for x. That's whatever's in the parentheses. So f of 9 means plug x equals 9 in. And then once you're here, you're following PEMDAS. Parentheses, exponents, multiplication, division, addition, subtraction. You notice there are parentheses here, so do the stuff inside the parentheses first. Of course, 1 plus 0.5 is just going to be 1.5. Now you notice I wrote parentheses on that line, but the parentheses no longer have an operation going on inside of them. So those parentheses are optional. They're there just for clarity. So it's not changing anything in the order of operations. So we've done the parentheses. Next up is exponents. So that means I got to do to the power of 9. Now, what is actually to the power of 9 here? It's the 1.5. People get tripped up on that sometimes. They start thinking that it's the 10 times 1.5 first, and that whole thing is to the power of 9, but it's not. It's only the one number it's attached to, so look out for that part. Now this is where we definitely need a calculator. When you plug that in your calculator, the 1.5 to the power of 9, it gives you like 38.44, and the number just keeps on going and going and going. I'm just writing down a rounded answer here. But leave the whole number showing on your calculator. That way you don't end up with like some rounding error in the middle, because that can happen very easily on these. So you still have the whole decimal showing on your calculator at this moment. And then the last thing we need to do is multiply it by the 10. And so with that number still showing on the calculator, you just press times 10. And when you do that, it gives us this. Now notice my final answer, I included this 3. I chose to go ahead and round it out to 2 decimal places. But I didn't have a 3 up here. The only reason I knew there would be a 3 there is because I kept the whole number on the calculator. So that's partly why we got to do that. All right, next one, same process. All right, so for this next one now, start by taking the 30 and plugging it in for t this time, because you'll notice it says a of t here. The t is in parentheses. Here the 30 is in the parentheses, so it's telling us that the t value is 30. Not like if you were thinking of it as x, it would have thrown you off, but it is an important detail that sometimes will crop. So I plug the 30 in for t, and then again we go through the order of operations. First thing you do is the stuff inside the parentheses. 1 plus 0.05, of course, just gives us 1.05. I now need to raise that to the power of 30. Gives me 4.32, and then the decimal goes on and on and on. I'm just writing down a rounded answer, but keep the whole decimal showing on your calculator again.
So are you supposed to just like...
All right, and then with that whole decimal showing on your calculator, you just say times 85. And again, I rounded it out to 2 decimal places. So this is what we're looking at for our final answer, 367.37. Now, these particular equations that we're looking at, they're structured in a particular way that we're actually going to be working with more as we go forward. But first, we're just going to be kind of using them and seeing how to evaluate them. But this is the type of situation where this happens in the real world and where this equation gets used a lot. Where we have some stock, in this case, that's increasing in value by a certain percent each year. So notice the percents are going to be related to this eventually. And it gives us this equation. And we want to know what will the value of the stock be after t equals 10 years. In other words, they've given us an equation and they've given us a t value. Notice it's the same basic problem. They've just given the words here to give some context about where this equation came from. And so if we want to figure it out, we go through the same process. We plug 10 in for t, and then use your order of operations from there. And so we do all the work and we get down to here. The only difference is between this problem and the previous problems is this one we were actually told that it was the value of a stock. And because it's talking about an actual value, we know that's a money thing. And so I just took my final answer and I wrote it in terms of dollars and cents. Which is why I was choosing to round stuff to the 100th place earlier. Because whenever we deal with money, we always round to the 100th place, and I know that's where we're headed with it.